All right, guys, welcome to Lesson 10 Concept Development video. We are going to be working on multi-digit multiplication, but this time we're going to be adding some decimals that we're multiplying by. So let's take a look at some of these. So let's go ahead and write the expression at the top of our page or notes. 42, oops, not 40, I wanted 43 actually, I'm sorry. 43 times 2.4. Okay, well, this is where from our fluency video, I want to decompose our decimals into the smallest place value. In this case, it's tenths. So really, let's rewrite this expression as 43 times, and we're going to decompose it into tenths. So we're really putting it into unit form. So it's 43 times 24 tenths. So I show that I know how to decompose my decimal by showing the next expression sentence. Well, I can rewrite that 2.4 as 24 tenths. That is going to make our life very similar to the lessons that we've been having. Well, this, oops, let me draw the right arrow. This one is new and kind of scary because we really haven't been multiplying by decimals in our standard algorithm yet. But this, well, this is the type of math we were doing last week, right? We've been working on 3-digit times 3-digit, 4-digit times 4-digit. So this should be a little easier actually if we convert it to unit form. So let's just go ahead and solve it with an area model real quick. Let's break apart 24 tenths on the top, but let's write the unit. Let's not forget that those are tenths and not 2 tens and 4 ones, because that is not what our number is. It's 2.4, 2 and 4 tenths. Well, the 43 just gets decomposed and broken apart on the side. Well, now we have 3 times 20 in this box, so that's 60. And remember, these are all tenths. And 3 times 4 is 12, and that's tenths. In my head, I'm already converting those back to decimal. 40 times 20, well, 4 times 2 is 8, with 2 zeros, 800 tenths. These are all tenths. 40 times 4 is 16. With that 0, 160. These are tenths. So this would be 72 tenths. And this one would be 960 tenths. Oops. Well, let me change color so I can represent these. Now, if I was thinking about tenths, if these were in the tenths place, I would regroup all of those tens of tenths to the left. So this would actually be equal to 7.2. Well, 960 tenths means I have to regroup twice, and this is going to be 96. Well, now I just need to add 96.0 plus 7.2. Remember, when we were practicing our addition of decimals, we needed to make sure that those were lined up. And then I can go ahead and just add my work, 103 and 2 tenths. Now, you could have, I converted and then added, right? Now, you could take, let me change my color again. You could take the tenths, add those together, and then convert. You don't have to convert and then add. If this is easier for your brain, go ahead and do it, because this would be 1,032 tenths. Well, if we look over here, that's exactly what that is. So it doesn't matter which way you go. You just need to show your understanding. Well, 1 and 1,032 tenths is really 103 and 2 tenths, right? Great job. Let's try another one. Clear our boards and practice this again. But this time let's do it with the area model and connect it with the standard algorithm. So let's go ahead and make it a little bit more challenging. Let's go ahead and make, and this time we're going to put the decimal first, just to be a little different. 15 and 6 tenths times 73. Well, remember, the commutative property doesn't allows us to change the order of the factors if we need to. But let's convert our decimal into unit form. Well, 15.6, if we jammed all of those digits into the lowest place value of tenths, it'd be 156 tenths. And we're multiplying that by 73. Well, once again, we took a problem, an expression that is a little scary because of the decimal, and made it very simple in something that we've been able to be successful with already in these last weeks. Because if I gave you this math problem, just 156 times 73, we're all able to be successful with that, whether we use the area model or standard algorithm. So nothing's changed here except we're talking about a different unit. We're talking about tenths. So let's go ahead and set up our area model real quick. Let's put 73 at the top. And then we'll do 6, 50, and 100 on the side. And remember, these are tenths. So everything inside of our area model is going to be tenths. Well, 6 times 70, 420. 6 times 3, 18. This is why it's so important to know your math facts. Look at the more that you know those very quickly, the simpler the math becomes. You just have to follow your steps. So 5 times 7 is 35 with 2 zeros, 3,500. 5 times 3 is 15, plus that, not plus that 0, with that 0 would make it 150. 100 times 70, well, 1 times 7 is 7, and then we got 1, 2, 3 zeros, 1, 2, 3 zeros, so we have 7,000. And then we have 100 times 3, which is 300. Now let's go ahead and add up our partial products. This would be 438 tenths. Remember, these are all tenths. This would be 3,650 tenths. And this would be 7,300 tenths. Now we can convert now, or we can convert later. Let's go ahead this time. Last time I converted first. This time let's convert after. So I'm just going to stack our tenths and add these up. That would be 8, 8. 6 plus 3 is 9, plus 4 more is 13, and then 11. And then remember, these are tenths. That's going to be the hardest thing, I think, is that people will forget that we're working with tenths when we're doing it this way. Now, don't worry, parents, if you're listening to this, I promise you we will be teaching them how we were taught as kids. This just helps make it a little bit simpler as we start figuring out how to place that decimal, where the decimal goes. So in the next coming lessons, you're going to start seeing us add it back in and stop using unit form, but showing standard algorithm the way we were taught. So no worries there. But let's try to help them understand what we're working with. Well, if we were thinking of this number, 11,388 tenths, and we were thinking about our place value chart, we know that this is, let me change color. We know that this is actually going to be 1,138 and 8 tenths. We know tenths is one place after the decimal. That's also another clue. So we only can have one place after the decimal. So we can just kind of think about bringing it back one place, right? So let's go ahead and set it up with standard algorithm and see how we do. So let's go ahead and set 156. Make sure you write tenths next to it. And if you want, you can put it in parentheses because it's just there to remind us of what we're doing. But here, remember, this is the stuff we've been practicing over the last couple days. We're going to take 3 times the top number. Well, 3 times 6 is 18. 3 times 5 is 15, plus 1 more is 16. 3 times 1 is 3, plus 1 more is 4. 468. I'm changing colors so that you can see this. Now we're going to be changing from the tens, from the ones to the tens times the top of the number. So we're going to go ahead and represent our tens place down there with a 0. 7 times 6 is 42. 7 times 5 is 35, plus 4 more is 39. And 7 times 1 is 7, plus 3 more is 10. Then we got 8 8, 13. Looks like it's exactly the same. Now this is where we got to remember that we're talking tenths, so we're going to bring that down. And I'm going to write the equals over to the left of it, actually, and just convert it. Remember, if we're talking tenths, it's one place in from, or one decimal, just one digit after the decimal. Wow, I couldn't get that out of my mouth. 1,138 and 8 tenths is the same thing as 11,388. Great. Now, let's go ahead and do one more together, and we're going to just do standard algorithm on this problem. So you notice how we're kind of scaffolding it out. So let's go ahead and clear a page or get a new spot on our page. And this time, let's go ahead and let's see if we can make it a little bit more challenging. See if we can get up to like, let's see, come on, I'm looking for a good math problem here. Wow, all right, I guess I'm just gonna make up one. Let's go ahead and do, let's see, 76 and 8 tenths. And we're gonna multiply that by, let's do 47. So remember, we're just going to rewrite this expression in unit form. So we're going to decompose our tenths. So we're going to think of us 768 tenths. So let's get the unit or the decimal out there and place the unit behind it, 768 tenths, and we're multiplying that by 47. I really want to see this step because that will help me understand if you are recognizing how to decompose our decimals. So then once we have that going, we can then just set it up. And remember, we want to rewrite that this is tenths so that we don't forget as we are solving. Well, 7 times, remember, we're going to do 7 times the top number. So 7 times 8 is 56. That's one of the hardest facts out there. 7 times 6 is 42, plus 5 more, 47. And then 7 times 7, 49, plus 4 more, 53. Okay, now we're shifting to the tens place times the top number. So remember, we're going to then go ahead and represent the tens place down here because it's not just multiplying by 4, we're multiplying by 4D. So 4 times 8 is 32. 4 times 6 is 24, plus 3 more is 27. 4 times 7, 28, plus 2 more is 30. Notice I cross off those regroupings because sometimes they can get in your way, and then when you're going to add these numbers back, it gets a little confusing. But remember, we got to bring down our unit. This is 36,096 tenths. Well, if we're visualizing that in the place value chart and we're shifting, regrouping to the left, we can also think of it simply as, well, tenths is one decimal place or one digit after the decimal. So I could rewrite this with one digit behind the decimal. So the answer to this math problem, which is scary when we look at it like this, becomes simply something that we know how to do with unit form. We just have to remember how to decompose our units so that we can get the answer. All right, 3,609. That is it for the concept lesson. We're going to take what we've practiced here and shift it onto our problem set. So I'll see you over there. Nice job.